6.4 Similar triangles and Unit 6 Similarity.
Now let's try and get a deeper understanding of similar triangles. Consider two similar triangles, triangle ABC and triangle PQR. Vertices ABC correspond to vertices PQR. Okay, these triangles are similar, but what else do similar triangles convey? What do they tell us about the sides and the angles? Well, quite a lot, I would say. First, let's look at the sides. Similar triangles always have their corresponding sides in proportion. In these two triangles, based on the correspondence, side AB corresponds to side PQ, AB and PQ. Similarly, side BC corresponds to side QR and side CA corresponds to side RP. Corresponding sides in proportion means the ratio of all three pairs of corresponding sides will be equal. The ratio of AB to PQ will equal the ratio of BC to QR will equal the ratio of CA to RP. AB and PQ are corresponding sides, BC and QR are corresponding sides, and CA and RP are also corresponding sides. But what does this actually mean? It means that each side is scaled up or scaled down by the same factor. Here, factor with which AB is increased to get PQ is the same as the factor with which BC is increased to get QR, or as the factor with which CA is increased to get RP. So remember, when the triangles are similar, the corresponding sides will always be in proportion. Now let's get to the angles. Similar triangles always have the same shape. What does that tell us about the angles? Yes, the measures of corresponding angles of similar triangles will be equal. Based on the correspondence of vertices, angle A corresponds to angle P, angle B corresponds to angle Q, and angle C corresponds to angle R. So angle A will be congruent to angle P. This can also be written as measure of angle A is equal to measure of angle P. It means if we take a protractor and measure these two angles, they will be equal. Similarly, angle B will be congruent to angle Q and angle C will be congruent to angle R. When the triangles are similar, their corresponding angles will be equal. So we can deduce all this when we are given that two triangles are similar. Here, we were given that triangle ABC is similar to triangle PQR. Is similar to can be replaced with this sign. So this can be read as triangle ABC is similar to triangle PQR. Actually, it also works the other way around. If we were given either of these conditions, we can say that the triangles are similar. Remember, either of the conditions. So if we are told that all pairs of corresponding sides are in proportion, we can be sure that the triangles are similar. Or even if we were told that the corresponding angles are equal, we can be sure that the triangles are similar. Look at triangle ABC. In this triangle, measure of angle A is given as 50 degrees and the measure of angle B is given as 70 degrees. Along with this triangle, we are also given triangle DEF. In this triangle, we are given that the measure of angle D is 50 degrees and the measure of angle E is 70 degrees. With this given data, we want to know if triangles ABC and DEF are similar. There are two conditions we have studied for similarity, the SSS and the AAA condition. Since we haven't been provided with the sides, the SSS condition won't work. The AAA condition says that if all three angles of one triangle equal the three corresponding angles of another triangle, then the triangles will be similar. So does it mean that we do not have enough data to know if the triangles are similar or not? Let's find out. We have been given that angle A is congruent to angle D, and angle B is congruent to angle E. We know that the sum of all angles in a triangle equals 180 degrees. So in triangle ABC, angle A plus angle B plus angle C will equal 180 degrees. Out of these three, we know the measures of two angles. Angle A measures 50 degrees and angle B measures 70 degrees. Angle A plus angle B is 120 degrees. So this can be written as 120 degrees plus angle C equals 180 degrees. Transposing 120 degrees to the other side, we get the measure of angle C as 60 degrees. So we got the measure of the third angle of this triangle as 60 degrees. Similarly, we find the measure of angle F in this triangle as 60 degrees. So the measure of this angle is also equal to the measure of this angle. Basically, with data of just two pairs of corresponding angles, we could figure out the similarity between triangles. So this condition, in which we need just two angles to be congruent for similarity, is called the AA condition. Let me repeat. Even if just two pairs of corresponding angles are congruent, we can say that the triangles are similar.
Determine whether the triangles are similar. If they are, write a similarity statement and explain your reasoning. Look at the two triangles to the right. Can we determine that they're similar based on their angles? In order to do this, we need to make sure that there's two angles that are congruent. Look at the two angles marked with red boxes. That means they're both right angles. If they're both 90 degrees, that means they're both congruent. Let's see if we can find another pair of congruent angles. By the triangle sum theorem, 26 plus 90 plus the measure of angle E has to be 180 degrees. If we subtract 90 and 26 from 180, we get that the measure of angle E has to be 64. If the measure of angle E is 64 and H is 64, that means E and H are congruent. Now we have two pairs of congruent angles, the right angle and E and H. Therefore, by the angle-angle similarity, triangle CDE is similar to triangle KGH. Show that the two triangles are similar. Let's look at A, triangle ABE, and ACD. Remember that if we can show just two angles are congruent or the same, then we can show that the two triangles are congruent. ABE is this little triangle. ACD is this big triangle. You might find it helpful to redraw these two triangles separately if you have trouble seeing what we're talking about. Notice that because the measure of A, B, E, and A, C, D are both 52, that they're congruent to each other. And notice that both triangles include the measure of angle A. Therefore, ABE and triangle ACD have to be similar by the angle-angle postulate. Again, looking for those two angles that are congruent in the two triangles. Now let's look at triangle SVR and UVT. SVR and UVT. And again, we're looking for angles that are congruent to each other in order to be able to say the triangles are congruent to each other. And notice that SR is parallel to TU. That's going to be important when we start looking for congruent angles. The easy one that I see is SVR and UVT, the angles, are vertical angles. Therefore, they have to be congruent to each other. And again, when we have parallel lines, we look for that Z so that we can find alternate interior angles. And we find that RSV has to be congruent to VUT by alternate interior angles. Again, looking for that Z shape in order to be able to find those alternate interior angles. And now we have two pairs of angles that are congruent to each other, SVR and UVT and RSV, TUV. Therefore, the two triangles have to be congruent to each other by angle. I said congruent and I meant similar. In the figure to the right, find the length of BD. So we just determined that a shape like this, where the two sides are parallel, those have to be similar to each other. Angle AEB and angle DEC are similar because they're vertical. Angles ABE and EDC are similar because they're alternate interior angles, making that Z. Therefore, the two triangles are similar to each other. Then we write a proportion based on similarity, and then we'll solve that proportion. AE is to CE as EB is to ED. Use your similarity statement to help you pair up the sides of the triangles. Again, AE is to CE as EB is to ED. Then take the side lengths from the picture. 4 is to 3 as X is to 5. Cross multiply. You get 3x is equal to 20. Divide by 3 and you get x is equal to 20/3, which in this example would be C. You can also use the side angle side similarity theorem, similar to the side angle side congruence theorem that we learned earlier, which says if you have an angle of one triangle congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So in this diagram, if X is congruent to M and XZ is to PM as XY is to MN, then you can say that the two triangles are similar. So there's three ways that we can say that two triangles are similar. The angle, which we saw a few examples of. Side, 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 which you saw in the first video. So if you can say all three sides are proportional, then we know that the two triangles are congruent. Or if you just have two sides proportional and their included angle congruent, then you can say that they're similar. Tell what method you would use to show that the triangles are similar. We have two sides. We know nothing about the third side. We don't know if these are parallel, so we were not going to be able to use alternate interior angles in this case. But we do know that angle ACB and angle ECD have to be congruent because they are vertical angles. So we'll begin by looking at the ratios of the corresponding sides. So we'll look at is 9 to 15 going to be the same as 18 to 30? And you might be able to just look at this. You might not. That's okay. So 9 over 15 is 3/5. So we want to determine, is AC over CD also 3/5? And it is. So remember how to reduce a fraction. 9 and 15 are both divisible by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. 18 over 30 are both divisible by 6. 18 divided by 6 is 3. 30 divided by 6 is 5. So we can say that the two sides are proportional to each other. And we already talked about the fact that these two angles, ACB and DCE, are vertical angles. So that gives us side angle side, or side angle side. And we can say that the two triangles are similar to each other. Now it's time to practice. I hope this video helped you.